Hello, everyone. We're live now. My name is Sergio Prinzan, and I'm part of the talent management team at Netlight Oslo. And I would like to welcome you to this webinar called An Introduction to Rust and WebAssembly. This is part of EdgeXR. For those of you who've tuned in to our previous sessions, welcome back. If this is your first time joining us, EdgeXR is a series of remote knowledge sharing events for both Netlighters and external participants. This is the fourth installment and last one before we take a break for the summer. So hope you enjoy it. Before we kick things off, I would just like to give you a short introduction on Netlight, especially for those of you who might not know about us from before. We are an IT and management consulting firm with 9 offices across the Nordics, Germany, and Switzerland, adding up to over 1,300 employees. We have been around for a bit over 20 years, and we help our clients digitally transform their business through what we call genuine consulting. So you can see here, our portfolio of expertise is quite broad, covering most areas within software development, design, and IT management. The example roles, which you can see on the right-hand side, show the variety in the projects that we usually work with, which allows us to really understand the client's business and create long-lasting value for them. So the speaker for today's webinar is one of our consultants, Alexander Heinz. He has experience in everything from writing front-end applications, setting up continuous deployment pipelines, to running complex servers and infrastructures in the cloud. As I just mentioned, he's going to be talking about Rust and WebAssembly. And he has a state-of-the-art home office and uses 3 different computers. But there's something, he can't use his camera, so you'll be seeing his presentation. But he's got something really good, exciting presentation in store for you. And one thing that I wanted to mention is we're going to have a Q&A at the end. So make sure to write your questions throughout the webinar, and we'll read them when Alexander is done with his presentation.
Thanks for joining today, everyone. As was just said, my name is Alexander Heinz. I work as a consultant in Netlight and have done so for about 3 years with a focus on web, both front end and back end. And today I'm going to be talking about Rust and WebAssembly. So first, a bit about Rust. What is Rust? Rust is a systems programming language. It's strongly typed and statically compiled. It has no runtime, or a very, very small one at least, and no garbage collection, though you can get garbage collection by using libraries. And why you would want to use something like Rust? One of the main reasons is performance. Rust compiles to native code that runs in C or C++ speeds, just like C and C++ does. But it also has the safety of GC languages like Java or C# or Go, in that it guarantees memory safety. It's an expressive modern language that has rich features, and it's a really nice language to work with. Over the last 5 years, it's won the most loved programming language in the Stack Overflow survey. Another key point of Rust is that the community, especially on Reddit, is one of the most inviting and helpful programming communities I've ever found myself, though that's obviously a bit anecdotal. Then over to WebAssembly. What is WebAssembly? WebAssembly is a new-ish binary instruction format. It's been around for a while longer than most people know, actually, but it hasn't seen that much adoption yet. It was initially intended for web, which is sort of why it got its name. It's a portable compilation target, which is also part of why it's got its name, and it's very minimal. And then why you would want to use something like WebAssembly. And there's quite a bit of overlap here with why you would want to use something like Rust, which is not an accident. One of the reasons why you would want to use something like WebAssembly is performance. It produces much more low-level code than what you would typically find on the web, because the web, as most people know, runs on JavaScript. Whereas WebAssembly ends up running a pretty lean stack machine and produces binaries that are smaller in size, that does not require parsing, so they're quicker to start up. But it still has all of the safety guarantees that you get from running something like JavaScript, which is that it's entirely sandboxed, and it does not get access to the environment outside of the browser or whatever else execution engine you run the WebAssembly in, unless you provide it. And we'll get back to that a bit later. It's portable. It's a binary instruction set that works on almost any platform. It is pretty easy to port to any platform because the instruction set is pretty small. So writing an interpreter or compiler for WebAssembly is much easier than writing the compilers that compile to WebAssembly. And it has widespread support. All modern browsers already support WebAssembly. And in addition to WebAssembly, there's something called WASI, which even fewer people have heard of. WASI stands for the WebAssembly System Interface. And it's a modular system interface for calling system APIs, or what you normally call syscalls, from WebAssembly. And it allows you to write anything from CLI applications to even graphical user interfaces in WebAssembly by using the existing system APIs on whatever platform you're running on. And then I have a list of some showcases because there are being built things currently which are quite impressive using both Rust and WebAssembly. And it's nice to see sort of the range of things people are building using these technologies. The first one is Compute at Edge by Fastly, which is a really interesting showcase because what they've done is they've taken sort of the CDN approach to the extreme by allowing their clients to run WebAssembly modules or logic at the edge nodes of the CDN, which is close to where the customer is. So you can think of it like instead of just having static cached assets close to the customer, you're also allowed to add logic, which runs, which starts up much faster than a Docker container and is allowed to fetch data and transform stuff very, very close to where the end user is. Another good example of typically what WebAssembly is used for today is TinySearch. TinySearch is a client-side document search or full text search based on Bloom filters. It's typically intended for static site generators. And the way it works is that you take the output from a static site generator like Gatsby or something like that, and you build a single binary containing the logic to do the search and also the search index. And then you ship that to the client on demand, typically when they focus in a input field or a search field. And then all of the search happens statically on the client, and it happens obviously very fast because you have all of the search data available on the client. So it's more like just the client-side filtering. On the other end of that scale, you have Vue. Vue is a full React-like framework for building your entire application in Rust that compiles to WebAssembly. And it's pretty young, but it's already pretty impressive what they're doing. So you have full access to all of the web APIs through typical foreign function interfaces. And you can build any sort of web application that you build using normal JavaScript tools in React with static typing and the expressive type system that React provides you. And the last, which is sort of like a showcase of a full application, or like what you would typically consider a desktop application and not a web one, is SketchUp. SketchUp is a fully featured 3D modeling program, and it runs entirely in your browser. So if anyone wants to test this, they can go to, I think it's app.sketchup.com, and you can start drawing 3D figures and using 3D modeling tools in your browser without having installed anything. And there's one more I just thought I'd mention very quickly, which is not on this list because I discovered it just yesterday. And that's a new project to be able to run WebAssembly workloads in Kubernetes clusters, which was announced pretty recently. So people are starting to experiment using WebAssembly for security workloads that has leaner startup than what you would typically use with Docker. Getting started with all of this is very, very easy. Installing Rust is typically a breeze on any operating system, both Windows and Mac and most Linux variants. And if it's not a one-click install from rustup.rs or one command install, then they will typically have instructions for how to build on your Linux distribution. The same goes for WasmPack. WasmPack is a one-stop for getting started with WebAssembly in Rust. They also have a one-click install for Windows and probably Mac OS, but if you already have a Rust up or installed on your system, it's also easy to install using a single Rust command. And then you can just start hacking. And WasmPack has good documentation on how to get started. And the tool itself will also very helpfully explain to you when you have configured things wrong. So in most cases, it's just up and running immediately. And it also has information about how to pull in the packages required to call web APIs like the DOM, etc. And that's all I have. As you can see, you can find me on both GitHub and Twitter, though I'm not very active on Twitter.
Yes, we got our first question, Alexander, and it is, which types of applications do you expect to get built in WebAssembly and Rust? Should we expect this to replace Electron-based web apps?
WebAssembly typically works very well with Electron. So I wouldn't expect it to replace Electron. I would expect it to work together with Electron because Electron is effectively a Chrome browser, and it's already present in actually more Electron tools than I think you would expect. For instance, Visual Studio Code, which is what most people use to build stuff like that currently, is an Electron-based app. And they use WebAssembly to do syntax highlighting.
Sounds good. Thank you very much, Alexander. I see there's a couple more questions already here. So the first one is, does you compile Rust to WASM for shipping to the web?
Yes. Or obviously Electron, as explained earlier, since Electron is effectively a browser. But yeah, U is U itself doesn't compile. U is just a library, so you compile it using the normal Rust toolchain for compiling to WebAssembly. But you install U in a project like you would install React in a client-side JavaScript project, and then build applications using components, which you defines, and properties, etc., just as you would from React, though obviously with a bit different syntax. But they have also defined their own sort of like JSX, which is called RSX, because Rust instead of JavaScript. So you are able to write code that at least on some level looks very much the same, though with obvious differences from Rust and JavaScript syntax.
Perfect, thank you, Alexander. I see you have a couple more here too. So next one is, heard a lot of good things about async/await in Rust. What's the current status on the ecosystem support there?
Yeah, async and await in Rust is a bit different from what you will find in most other languages that have similar features. For once, it's a pull-based system instead of a completion one. And that has some challenges, and one of the reasons they've done it this way is that Rust didn't want to define how the executor of async code should look, and didn't want to bundle that with the std library. because then everyone would pay for it, regardless of whether or not they use it. And one of the goals of Rust is to be as lean as possible, so you'd only pay for the features you use. That means there are currently more than one async executor, and in some cases they are incompatible. So in large applications, they use a lot of async. No, wait. You typically end up to use more than one executor, which has some implications for memory usage and potentially performance, so that's very unlikely to really hurt. The main thing is binary size.
Perfect. Thank you, Alexander. And the next question is, I saw Parcel being able to ship Rust/WebAssembly. Any experience with it?
I don't have any experience with Parcel. I have some experience with shipping WebAssembly from Rust in Webpack, and I imagine it should be more or less exactly the same. The WASM pack Rust tools actually generate like package.json and JavaScript files for including the WebAssembly in bundlers. So most bundlers should just be fine with it, though you might need to configure them how to deal with .wasm files.
Sounds good. And okay, I see the questions are in. There's another one. Which types of applications do you think will be getting the most out of using this tech?
Well, I think one really neat use case is the one they have in Visual Studio for doing syntax highlighting. The main issue there is that the standard for doing syntax highlighting in editors is files called TM bundle. I think they're from old TextMate, which I believe is an editor from OS X, but I'm not entirely sure on that one. And they use a regex specification, which is different from basically what everyone else uses. So to make sure that everything was working correctly, they had to include a different regex implementation than what you had in Node by default. And recently they rewrote that to using WebAssembly instead of I think they used a native module before, and they managed to get 33% speed up, I believe, probably due to removing some foreign function friction.
Perfect. Let's see. The next question is, where would you say Rust is not the right tool for the job, where C, Go, Python is better?
Well, personally, I would never reach for C if Rust is an alternative, but Rust isn't always an alternative, but it's getting there, definitely. One of the key areas where there's been quite a lot of churn in getting Rust to work is microcontrollers, and it does work on quite a few of them, which is really exciting. So that's definitely something I'm going to be playing more with, though the C tooling there is normally more mature. Also, currently Rust mainly builds on LLVM, so you need a platform that can build using LLVM and not GCC. But there's work on splitting it up so it supports more than one backend. As for Go, in my preference, I would always use Rust instead. And what was the third language you had? Python? Yeah, same there. The only thing I can see where Python might be more usable is for writing quick scripts, but I don't use Python for that, and I either use Bash or JavaScript. So yeah. But again, there's preference here, obviously. So it depends a bit on what you want to some extent. But there's been, if you read on the Reddit for Rust, there's quite a lot of articles on how to eat up what you would normally do in Python with Rust, like machine learning, for instance.
Sounds good. Thank you, Alexander. I got at least 3 more questions. So the next one is, what are the current roadblocks for a large-scale adoption of WebAssembly?
That one I'm actually not quite sure. I think one of the main one is that people aren't aware that this technology is actually somewhat mature and available in all browsers. So you can build something in WebAssembly and have it run just as easily as you would with JavaScript. And it feels a bit like we were with WebAssembly, the way we were with JavaScript about, I don't know, 10 years ago, where you had to have no script and support everything running without JavaScript. Today, we have mostly stopped doing that. The most you do is display some sort of warning that you need to enable JavaScript to run this page. And most pages today don't necessarily work without JavaScript. WebAssembly is somewhat of the same in that people would like to have graceful fallbacks because they believe that there are users who use browsers that want to port it. And one of the cool things about WebAssembly is that you can actually have a WebAssembly interpreter in JavaScript. So anywhere JavaScript runs, WebAssembly can run, though in that case, not necessarily natively, but it runs natively in all the major browsers. And if I'm not mistaken, and I might be here, it was also added to the latest version of IE before they stopped developing on that. But that might be me misremembering.
Right, thank you, Alexander. The next one is, you mentioned Docker workloads being replaced with WebAssembly because it is more lightweight. To what degree do you expect this to happen? Do you know any other pros and cons with using Docker versus WebAssembly?
Some obvious pros with Docker is the fact that you have a more normal operating system included in your container, which is also part of the con, depending on how you look at it. You can run multiple processes in the same Docker image, which, as far as I know, isn't really recommended. But in some cases, it's very useful because you want to run programs that aren't intended to run as, for instance, process number 0, which causes issues for some processes. Whereas WASM would be more like a single executable that you run in a sandbox. So it's more comparable to just a exe or a normal executable, except that it runs in a sandbox.
Okay, thank you, Alexander. The next one, I love so many questions. That's great. I might have come in too late to hear about this, but how does Rust handle memory safety and garbage collection? How efficient is it?
Rust doesn't generally do garbage collections. There are libraries for which you can sort of include smart pointers that has GC built into them, though they do require some caution on the programmer side, mainly to do with the fact that they need to be able to trace all usages. Though how Rust does memory safety is it uses something called a borrow checker to check the liveliness of all variables. So Rust knows whenever a variable is live and how many references there are to it, etc., all at compile time. So there's no runtime cost for it. So basically what you can think of it is automatically insertion of delete statements when a variable goes out of scope.
Sounds good. I see this one. Yeah, that one's already answered, I believe. So that we can wait a few more seconds. See if there are any other questions. Now we can wrap things up. Do you have any last thoughts, Alexander, or anything in your head? There's a lot of covered a lot with the questions as well, so that was very good.
I think I covered most of what I have.
Sounds good. And I think let's see, not a question, just a shout out. Great job. Thank you.
Thank you.
Very good, very good. Yeah, then I think wait a few more seconds, but just in case anybody, if there are any other things you'd like to bring up with Alexander, you see his contact information here, or I'm sure on LinkedIn as well. He would be more than happy to answer your questions. And yeah, I think looks like that was the last question or comment. So maybe we'll just wrap it up here. So again, thank you very much, Alexander, for this webinar and for everybody who was attending and for all your questions. And again, if anything else, you can contact Alexander directly, and I'm sure he'll answer your thoughts or share his thoughts with you. That's good. Thank you very much, Alexander, and everybody have a good rest of your day.